Yes. So let's throw out there some alternate a couple different scenarios of how this could have gone. Suppose, all right. Let me all right. So this is the main idea. So I'm going to work some time to make sure you understand the main idea of what's going on. Now, so what's the idea? So for a moment, forgive me. I'm going to work in z-scores instead of x-bar values, just because it'll be quicker and easier to calculate probabilities. So let's say so in this case, our z-score was 2.28. What if we had a z-score of 1.7? Do you think that does that make mu equals 4 is the same as z equals 0. So let's just say that. So does this make the mean more likely or less likely? The fact that it equals the mean. Alright, maybe it'll help if I put in the actual values. So this would be 4, and alright, let me try an x-bar value. What if I got an x-bar value of 4.2? Does that make our original guess of 4 seem more likely or less likely? Compared to, from our sample, we got 4.5 in the first case. And we said we're 0.988 confident, over 98% confident that mu is greater than 4. Suppose we did another survey and we got an x-bar of 4.2. So what do you think about our original guess of 4 now? How do we think of our guess of mu equals 4? Does that seem like a better guess now or a worse guess now? This seems like a better guess. Okay. So let's figure out the numbers. Okay. So first of all, the z-score equals 0.2 divided by 0.2191. So the z-score is 0.9128. And then the probability .8193. So this would be 0.8193, and this would be 0.1807. So now what would we say? Now we would say we are 0.8193 confident that mu is greater than 4. Mu equals 4 looks like a better guess, so our confidence that mu is greater than 4 is lower. Does that make sense? Okay. What if, make more room still. Not to the left. Well, when I get to the terminology part, I'm gonna say specifically what each of these things is called. It's the unshaded area is your confidence, which we're gonna lay out more specifically in a minute.
The thing that I'm confused about is how you're taking that number.
What number?
Like the number to the left or the number to the right. So is if mu is greater than 4, it goes to the left. Like, if that's because you have to get aside.
Right now we're doing mu.
Scale.
Right now we're doing mu is greater than 4, so we're going to shade on the right side. In another case, maybe we'll do mu is less than. Maybe we'll do in another case mu is less than 50, and we'll shade to the left.
Yeah, so do you take the opposite side of that? That's what I'm saying. If
The-
you're shading to the right, you take the opposite number. you
The
say that's how
the
confident you
confidence
are.
comes from the area of what I call the fat middle. But we'll see that as we do more examples. That
So then
yeah.
that's shading in that part where how you're actually getting the number to put down. Like I understand how you get the number.
Okay.
But I don't understand which number you take to actually put down. That's how confident you are. That's what I'm
Okay.
confused.
Well, let me do one more example, and maybe this will help clear it up. So, what if we had, let's see, 4 point, let's see, yeah. What if we had 4.8? What do you think our final conclusion is going to be? How do we feel if from our sample we got 4.8? Are we going to be happier? Are we going to feel better or worse about the guess mu equals 4? We're going to feel worse about our guess mu equals 4. So in the first example, we were 0.988 confident that mu is greater than 4. And in the second example, we were 0.8193 confident that mu is greater than 4. So what do you think is going to be the result, just in terms of bigger or smaller, in this case?
More than
Yeah. We're going to be even more confident that mu is greater than 4, because we're less happy with mu equals 4. So let's actually go ahead and figure out the numbers. So first let's find the z-score. The z-score is 0.8 over 3.6513. Well, there you go. Oh, I forgot to shade. So 0.9999, 0.0001. So what's the conclusion? Exactly that. Oh. We are 0.9999 confident that mu is greater than 4. So, does that make more sense? So, I mean, what should be clear, what I hope you see, is that whatever your guess is, the further away you get data from your sample. The further away the data from your sample is from your guess, the less happy you are about your original guess, and the more confident you are that it's, in this case, greater than, or in another case, less than, depending upon how the hypothesis is set up. And where do we get these numbers from? We get these numbers from the calculations that we've been doing all along. All right, Emma. I'm sorry? So yeah, at this point, so we're already at 0.9999 confident. So if you want to see a distinction, you'll have to go to like 5 decimal places or 6 decimal places. So it gets like a little bigger, but by a very small amount. Oh, if the 4 point, I'm sorry, I thought you meant the z-score.
Yeah.
If the 4.8 is 3.8, okay. That's actually tricky to explain, but let's put it this way. If our guess is 4, and the result from our data is 3.8, what are we going to think about the claim that mu is greater than 4? Yeah, it's ridiculous. So we're going to get very, very low confidence that it's greater than 4. You might want to start thinking about, is it less than 4? But since in this case we're asking about the claim, is it greater than 4, we would get some really, really low level of confidence that it's greater than 4. Does that make sense?
Can you go back to the wording of the question for
Okay.
How are you using the X bar 4.5 and you show the line where you say that the river, this river exceeds 4.
Right. Well, so the thing is, there's two things. Remember what is a hypothesis test? First, you make a claim, then you get data from your sample. So in this problem, what's the claim?
We have the condition of exceeds. So that
Right. So that's the claim part. So part 2, we get data from a sample. What's the data from the sample? Exactly. So those are separate parts. So the claim is a claim about the population, so that's mu equals 4, mu greater than 4. Data from the sample is X bar, and that's 4.5.
Basically include the hypothesis to the patient.
Right.
And all the values are usually result plot.
Right. Right.
So, after they conduct the sample and they got all the results, the claim is to see if it's reasonable or not, if it makes sense.
Informally, yes.
Actually,
Yeah, informally, yes. But now I've shown you some of the proper terminology for how we say that, and now I'm going to show you the rest of the terminology for all these things. All right, and Stacy, this is going to answer your question a little bit as well. Okay, so I've shown you one way of writing down the answer using what I call the terminology of confidence. Okay, there's another terminology here. That terminology is, I need more room. Okay. So the other terminology is the terminology in terms of p-value and then also significance. So in the original problem, what was our confidence? 0.9888. So equivalently, we can say that our p-value is 0.0112. I didn't tell you anything new, I just gave you terminology. P-value, P doesn't represent anything. Yeah. P-value represents the shaded area. So the confidence is the unshaded area. I like to call it the fat middle. And then the p-value is just the shaded area. And what's the relationship between confidence and p-value?
1 minus.
They have to, right, 1 minus, so they have to add up to 1. Okay. So let's go back and say some more things. So we are 0.988 confident that mu is greater than 4. We can also say p-value equals 0.0112. And the third way to state this is in terms of this language that's sort of antiquated, but it's still used. So notice that we made our final statement that we're 0.988 confident that mu is greater than 4. Well, now let's go back and interpret that in terms of the original hypotheses. The original hypotheses, we were saying, well, HO says mu equals 4, and H1 mu is greater than 4. So what did we wind up doing? We wind up saying we're pretty confident that mu is greater than 4. So another way of saying this is that we reject the first hypothesis and accept the second hypothesis. The second hypothesis being mu is greater than 4. So we say we reject H0 and accept H1, and we do it with how much confidence? With 0.9888 confidence. Now I don't like this last method for a lot of reasons. One of them is that it always says everything HO, H1, and you kind of forget what the original problem was. But just remember, rejecting HO and accepting H1, what's H1 in this problem? That mu is greater than 4. So that's sort of what we were talking about. So this reject accept method was done for a long time. It's in the world of statistics, this method is falling out of favor. That hasn't quite gotten into the textbooks yet. So a lot of the problems are still asked in this way, and then some of the online homeworks, it'll give you multiple choices. So some of the answers are phrased in this way. So as far as I'm concerned, I always think of everything in terms of confidence, and then I translate it into accept, reject.
So how do you write on the test? Confidence and then confidence? What do you?
So as far as this question, you can just answer and put this way. You should be able to.
Once you get to the confidence
Each of these three statements, you should be able to understand what they mean if you see it. When it comes to writing down an answer, you only have to write it down one way.
Do you want to write down the rejection? Or we were talking?
I'm usually going to write it down in the confidence way. You can write it down however you like.
But in the book, in the homework, they're going to want to reject.
Like I said, since a lot of those problems are multiple choice, you simply have to read it and know what it means.